Right, folks. Shh. So number 3. So a satellite is a special case of a projectile whose curve matches that of the Earth. So that it never lands. But here's a key idea. It falls continuously. Okay, so number 4. A satellite in a higher orbit will have a larger period, which is our time of orbit, similar to the period of a wave is the time for a wave. So that should be a larger period. Have a larger period than one in a low orbit. Okay. Uses for satellites include monitoring of weather, global positioning system, GPS. What else did we have? So the idea is we could use the full EM spectrum, right, to monitor the Earth. There's things like vegetation could be monitored using that. With the International Space Station. Which included experiments on how things survive in low gravity, but also the idea of having telescopes that point out the way. And communication. E.g. satellite TV. Let's say number 6 seems to be a duplicate, so we just put C4. So 7 and 8. So a geostationary satellite is one which appears stationary when viewed from the Earth. So if you think about your dish for satellite TV, it doesn't have to move because the satellite, right, appears stationary for it. And that's achieved when the satellite is orbiting at the same rate as the Earth. So this is achieved when the satellite has an orbital period of 24 hours. Now it has to be above the equator and has to be going in the same direction as the Earth is spinning. That's a kind of given. So a satellite orbit with a height of 36,000 kilometers above the surface of the Earth. Gives you that period of 24 hours.